One thing you've got to be mindful of when you're working with differential calculus is the relationship between tangents and angles. When we talk about tangents, normally you would have learnt in year 9 that tangent is derived as m being the slope, and the slope is given by the rise over the run, not run. Okay, so m equals rise over run, and there's different iterations of this equation which you would use through linear algebra and so forth. But when we talk about dy dx, remember dy dx is the gradient of the tangent, and this can be described commonly as m. So the two are related, but what we want to ascertain here is what happens when we have an angle. So if I set up just any set of Cartesian axes, okay, and I put a line through here, I'd have some angle there which is generally put to the positive end of the x-axis. And this angle we can find by its rise over its run. And if we go back to circular functions, we know that if I'm looking at my rise and run, okay, this being my opposite, this being my adjacent, and my hypotenuse here, okay, I know that my tangent of the angle is going to be equal to opposite over adjacent, rise over run, and this equals m. And in this sense, we can say that theta equals the inverse of the tangent by m. Now, there is one little aspect of this that we need to consider, and that's when we're dealing with negative gradients. So gradients that look like so. We still have this formula, theta equals the inverse tangent times by m, but what we would find with our negative gradient is that that theta is normally expressed here, and it will generally be expressed as a negative angle, let's say negative 60 degrees. And we can find what the angle is here by saying, well, that's 180 degrees minus what, or plus what that theta is, okay, because that would be negative 60 degrees. All right, so you just need to be aware of two things you need to be aware of. One, this equation, okay, you must be aware of that. And two, how to deal with negative gradients. Okay. So let's have a look at our problem. So we've got two problems which is taken from our text, and I'm not going to do all of them. In fact, I'm going to include, I thought that this might work, I'm going to include this one, this problem here, C. So we're going to have a look at 9a to get us started. So if I look at 9a, first thing that I'm going to do is I'm going to say that my angle here is 45 degrees. I'm just going to do a rough sketch on a set of axes, 45 degrees, and this triangle would look something like that. And I know by my exact values with circular functions, I have 1 square root of 2. Okay, now my m here will be my rise over 1, which equals 1. And therefore I can say that if I deal with fx, so my function here is fx equals x squared minus x, my derivative function, which is going to be really important, is 2x minus 1. And what I'm saying here for this particular equation is that for this function at 45 degrees, m equals 1, which means this function f dash x, that has to equal 1. So what I'm going to have is 1 equals 2x minus 1. And what I'm really trying to find is what value of x does this exist? So I get 2 equals 2x, and x equals 1. And that's the answer that we have for the correct answer for 9A. I can do a similar thing when I look at 9B. Okay, so here my angle is 135 degrees. And what I might do is on my set of axes, is this 135 degrees, and remember it says with the positive direction of the x-axis, well this translates to 45 degrees like that. And if I draw my triangle with the 45 degrees, it looks like that, and that means m equals -1. Now if I'm saying f dash x equals -1, what I get is -1 equals 2x minus 1, 0 equals 2x, x equals 0. And there's my answer for 9B, which is great. If I look at 9C, and hopefully I have enough room to be able to do this, well this one says 60 degrees, and it's in the positive direction of the x-axis, so I can keep that as it is. But what I'm saying with my 60 degree angle is that I'm going to have root 3, 1, and 2. Because I know my exact values with the identity triangles, so I can just use them to my advantage. And what I'm going to say here is that my gradient is actually going to be root 3 on 1, which is just root 3. And this leaves me with root 3 equaling 2x minus 1, because remember, this equation here is f dash x, so I'm sort of just skipping along as we can do it. And then if I want to find the value of x, I'm going to say 2x equals 1 plus square root of 3, and x equals 1 plus square root of 3 on 2. Again, correct answer. Seems like I'm understanding the concept. For question 10, however, what we're dealing with is we haven't been given an angle, we're being asked to find an angle at a specific point. And I'm going to start with question 10. So this is going to be question 10A. And what it says is y equals x squared plus 3x at x equals 1 and y equals 4. And what we're being asked to establish is to find the angle. So we can find what dy dx is going to be. And dy dx, we just simply derive the equation plus 3. And we're going to say when x equals 1, dy dx is going to equal 2 by 1 plus 3. dy dx equals 5. And then I'm going to use my equation here where tan theta equals m. This is saying tan theta equals 5. And to be able to find theta, what I'm going to use is my inverse tan 5. And because I should notice that here, I should notice that this this gradient or this slope is positive. Therefore, I don't have to worry about the orientation of the graph. I can just automatically do this calculation as is. So, and when I plug it into the calculator, remember you're going to have to change your calculator into degrees, not into radians. You get 78.69 degrees, okay, with, and I'll just be a little bit technical here with this question. I won't be technical with the other questions. Okay, so that just means that the angle is born like that. So what it means is that we've got an angle here, 78.69 degrees, and that means that my slope here is 5. Okay, if I look at question B, so 10B, what this says is y equals minus x squared plus 2x at x equaling 1, y equaling 1. I would find what dy dx is going to be. Dy dx equals negative 2x plus 2. I will say here when x equals 1, what does dy dx equal? Dy dx equals negative 2 by 1 plus 2. This so happens that it's 0. So this is quite easy to think about. So what we have here is, I'll just do this in another colour though, we can have a line or a tangent that's just sitting flat along there. Now it might be at a different point. It could be at this point here, 1, 2, but the tangent goes like that. And what we can say is that because it's at that point, no angle is made. With the x-axis, because they're running parallel. That's an interesting kind of question to consider, and maybe something that is a bit of an anomaly with most of the questions that you would do in this respect. If we look at question 10, so question 10F, this one is y equals x to the 4 minus x squared, and we're looking at the point x equals negative 1, y equals 0. And we're going to find dy dx here. So quick differentiation of it, of the term. When x equals negative 1, dy dx equals 4, negative 1 cubed minus 2, negative 1. And this will end up equaling negative 4 plus 2, which equals negative 2. Now, I've selected this question purposefully because I want to hone into how do we deal when we have negative gradient. So we want to think about that when we have a negative gradient. So we're going to apply the same rule, tan inverse negative 2, and we get this angle negative 63.43 degrees. Now a graphic is always handy. We'll always say that a graphic is really handy, and that 63.43 degrees is there. Now when we're trying to ascertain that angle that's occurring with the positive side of the x-axis, what we're going to do is we're going to say that this angle equals 180 minus 63.43 degrees. 180 degrees. Think about it, between here and here, or this point and this point, you have 180 degrees. Obviously you take away this angle and you're going to be left over with the angle. So we're going to say that the angle actually equals 180 minus 63.43 degrees, and the angle here is 116.56 degrees. Okay, so which is correct. So I hope this helps, and good luck with everything else.